You know that smell? You pull a towel straight out of the washing machine, bring it up to your face, and there it is. That damp, sour, musty funk that makes you wonder if the machine even did anything at all. You have tried hot water, you have tried extra detergent, you have thrown in vinegar, baking soda, maybe both at the same time, hoping that this combination would finally be the one that works. And for about a day, maybe two, the towels smell okay. Then you use them once, hang them up, and by the next morning, the smell is back. Like it never left. Like it was just waiting for you to let your guard down. And the frustrating part is that you are doing everything right. You are washing regularly. You are not leaving them sitting in the machine. You are following every tip you have ever come across, but nothing sticks. So you start to think maybe your towels are just too old. Maybe your washing machine is failing. Maybe this is simply what happens to towels over time and there is nothing you can do about it. What nobody knew, at least outside of Japan, is that the problem was never the dirt. It was never the detergent, and it was never your machine. The problem is something alive, something actively growing deep inside the fabric of your towels right now, and every solution you have tried has completely missed it. But this story does not start with the solution. It starts with the organism itself and why it has been outsmarting your laundry routine for years. There is a bacterium called Moraxella osloensis, and it has a very particular talent. It thrives in damp, warm environments with a steady supply of organic material. Your bath towels, used daily and hung in humid bathrooms, provide the perfect habitat. Every time you dry your body, dead skin cells and moisture get trapped deep inside the twisted cotton fibers. That is breakfast, lunch, and dinner for Moraxella osloensis. It feeds, it multiplies, and it forms dense bacterial colonies that burrow into the fabric at a level that water flowing through a washing machine drum simply cannot reach. And this is the part that makes it so frustrating. The bacteria does not just sit there quietly. As it metabolizes, it produces a specific chemical waste product. That waste is the exact sour, musty smell you keep detecting on your towels. You are not smelling old detergent. You are not smelling mildew in the traditional sense. You are smelling bacterial excretion. And the colony producing it is alive, protected by a sticky biofilm layer that it secretes around itself like a microscopic shield. That biofilm clings to the interior of each cotton fiber, making the colony nearly impossible to dislodge with water flow alone. Every time your towel gets damp again after use, the colony wakes back up, feeds, and starts producing waste all over again. Japanese researchers were among the first to isolate Moraxella osloensis as the primary culprit behind persistent towel odor. A study published by a team at Kansai University tested used household towels and found that this single species dominated the bacterial population on fabrics that smelled musty even after machine washing. What they discovered was revealing. The bacteria has a survival threshold that sits well above the temperatures used in standard household wash cycles. A typical warm wash runs between 30 and 40 degrees Celsius. Moraxella osloensis does not begin to break down until temperatures exceed 50 degrees Celsius. So every wash cycle you run is warm enough to rinse surface grime off the fabric, but nowhere near hot enough to penetrate the fibers and destroy the colonies embedded inside them. You finish the cycle, the towel smells briefly like detergent, and within hours of its next use, the surviving bacteria picks up exactly where it left off. This is where the story takes a turn nobody expected. Because once you understand that the problem is biological, not just a matter of cleanliness, every common household fix suddenly reveals itself as a surface-level treatment. Vinegar is acidic, and it does temporarily suppress the odor by altering the surface pH of the fabric, but it cannot penetrate deep enough into tightly woven cotton fibers to reach the bacterial colony at the core. The smell returns within a day or two because the source was never touched. Baking soda works as a chemical deodorizer, neutralizing the acidic waste products on the surface. But again, it treats the output of the bacteria, not the bacteria itself. Even scented laundry boosters and fabric softeners are just layering fragrance over an active colony. The perfume fades, the bacteria keeps producing waste, and the cycle repeats. So you are not failing at laundry. The tools you were given were never designed to solve this particular problem. You could wash your towels 10 times in a row with the best detergent on the market, and if the water never exceeds 50 degrees, the colony survives every single cycle. The smell comes back because the source of the smell never died. And until you address the biology, nothing changes. If you are finding this useful, hit subscribe. I cover the science behind everyday problems like this every week, and the next one goes even deeper. And the timing of what happened next is almost too perfect. Because while the rest of the world kept throwing vinegar and baking soda at the symptom, Japanese households had quietly been using a completely different approach for decades. The product is called sodium percarbonate. Walk into practically any Japanese home and you will find it somewhere in the laundry area, usually in a plain white bag with minimal packaging. It has been a household staple in Japan for so long that many families consider it as basic as dish soap. It looks like coarse salt. It costs very little. And it works on an entirely different chemical principle than anything you have probably tried. Sodium percarbonate is classified as an oxygen-based bleach, and it is fundamentally different from the chlorine bleach common in Western households. When dissolved in hot water above 50 degrees Celsius, sodium percarbonate breaks down into two active components: hydrogen peroxide and soda ash. The hydrogen peroxide is the critical part. It is a small, highly reactive molecule that can penetrate deep into cotton fibers, far deeper than liquid detergent or vinegar ever could, and it destroys bacterial cell walls on contact. The soda ash creates an alkaline environment that further destabilizes bacterial colonies and dissolves the biofilm they hide inside. Think about that for a second. The biofilm is the protective layer that shields the bacteria from your regular wash cycle. It is the reason Moraxella osloensis survives where other microorganisms do not. Sodium percarbonate does not just kill the bacteria on the surface. It dissolves the fortress the bacteria built around itself, and it does this without the harsh chemical smell of chlorine bleach, without damaging colored fabrics, and without leaving the kind of residue that stiffens towels over time. Japanese brands like Miyoshi and Shaban Dama have been selling it as a household staple for years, but any pure sodium percarbonate from anywhere in the world performs exactly the same way. The Japanese soaking method works by submerging towels in hot water at 50 to 60 degrees Celsius with dissolved sodium percarbonate and leaving them for 1 to 2 hours. The temperature is precise for a reason. Too cool, and the percarbonate does not fully activate. Too hot, like boiling, and the compound breaks down too fast, burning through the oxygen before it can do its work. The sustained exposure at the right temperature gives the hydrogen peroxide time to penetrate every layer of fiber, dissolve the biofilm, and destroy the bacterial colonies at their root. Japanese cleaning experts recommend periodic agitation during the soak to cycle fresh solution through the folds of the fabric, forcing oxygenated water into every crevice. The water turns gray or yellowish brown during this process, and that discoloration is not dirt. It is dead bacteria and the dissolved remains of the biofilm they had been living inside. A standard washing machine cycle would never extract that material because it was never designed to. But here is the detail that separates this from just another cleaning trick. And it might be the part that changes the most about how you think about your towels. Now, the towel method you just learned is one of 32 Japanese cleaning techniques I broke down in a handbook called SOUJI, the Japanese Home Secrets Handbook. It is 251 pages. Every method includes the exact ratios and the science behind why it works. It is a single PDF, and the link is in the description if you want the full collection. But for now, let me show you the part of this towel method that ties everything together. Japanese households do not just treat the bacteria after it has established itself. They prevent it from ever getting a foothold in the first place. The method has nothing to do with washing. It has to do with drying. In Japan, towels are hung fully spread open between uses with maximum AIR flow reaching both sides of the fabric. Instead of folding a damp towel over a bathroom rack where the inner layers press together and trap moisture, Japanese families use clip hangers or wide drying racks that keep the entire surface exposed to circulating air. Some hang them outdoors in direct sunlight, which adds ultraviolet exposure as a natural antibacterial layer on top of the drying itself. The logic is rooted in the same biology. Moraxella osloensis requires sustained moisture to reproduce. Every hour your towel stays damp after use is another hour the bacteria colony has to feed and expand. A towel folded over a rack in a steamy bathroom can stay damp for 6 or 8 hours. That is 6 or 8 hours of uninterrupted bacterial growth between uses. If the towel reaches complete dryness within an hour or two, the bacteria cannot multiply fast enough to rebuild its colony and produce that waste odor. The drying method is not a supplementary tip. It is the other half of the solution. Japanese homemakers understood that killing the existing bacteria only solves half the problem. Controlling the environment that allowed the bacteria to thrive in the first place is what makes the result permanent. Combined with a brief monthly maintenance soak in sodium percarbonate, this two-part approach means the bacterial colony never gets the chance to reestablish itself. The monthly soak destroys whatever trace colonization occurred during the weeks in between, resetting the clock before the bacteria can build enough numbers to produce any noticeable odor. And the drying discipline ensures conditions stay hostile to regrowth between treatments. After a few months of this routine, the towels barely develop any smell at all. The cycle of washing, hoping, and smelling breaks permanently. But this is not really a story about towels. It is a story about how an invisible organism exploited a gap in the way the entire world does laundry, and how one country's quiet, practical approach to household science solved it decades before the rest of us even understood the question. We spent years buying stronger detergents, fancier fabric softeners, and viral cleaning hacks that addressed everything except the actual cause. Meanwhile, a bag of coarse white powder sitting under a kitchen sink in Osaka was doing more than all of it combined. The frustration you felt every time you sniffed a freshly washed towel and caught that sour note was never a personal failing. It was a biological reality that nobody had explained to you until now. Remember that damp, musty smell you thought was just what towels eventually become? It was never inevitable. It was Moraxella osloensis. And now you understand exactly why it was there and exactly why it does not have to be. If this changed the way you think about something as simple as a towel, share it with someone who has been fighting the same invisible battle. Hit subscribe so you do not miss next week's video. I will see you in the next one.